All right, so I think we can start. So for anyone that doesn't know me, I'm Leonardo Lima. Oh, Leonardo Lima is my name, actually my name and my handle on the social networks and also in GitHub and all of that. I wasn't sure if I should talk in English or in Portuguese, but I'll do it in English because I think there are different folks here. So I'll keep talking in English. So my talk today, like, have like a funny name, but actually it's more. Oh, my screen blocked. Yeah. So yeah, fuzzing around and finding out on BTK, and more actually like a story of the challenges and the lessons that I learned while trying to implement fuzzing in the BTK. And as I was mentioning, like I'm a contributor on BTK. I saw familiar faces here that from previous contributors. Thanks for your work. And yeah, I'm not like the biggest brain on fuzzing. We have some other guys here and also throughout the conference with better like knowledge about fuzzing and all of that. This is more like to give like a brief overview on how fuzzing works, why we wanted to apply it to BTK, and all the challenges and the issues that I faced when trying to do it. So why fuzzing? Like, just as a broad motivation, we have like a variety of ways that you can test your application. Like we have like unit tests, integration tests, and also fuzz testing. And the broad motivation was like, Bitcoin is like an adversarial environment and an adversarial network, and you need to prevent like any bugs and crashes from your application because any of the type of the bugs that you can face could lead to either loss of funds, privacy leaks, or DOS, and then in BTK we can face all of them. Like basically, if you have like any problem in your security and your privacy and any DOS for any application that uses BTK, you can also lock the person out of the wallet. It can like recovers and resync, but it's like an API serving the wallets. You can also basically DOS the whole server. And as I was mentioned, like, we have like unit tests and integration testing, like, but those covers the known things, like that you know about your application and know about the project. So you can like test for expected and correct inputs, for the expected and correct behaviors, and then you can know what your application is doing right or wrong. And with that, you can just assure that it's testing on what you know and what the inputs that you were expecting you actually created by hand. And like fuzzers, on the other hand, covers the unknown. Like in my opinion and in my vision, you can also try like for more format or unexpected inputs, that those are handled properly in your application and doesn't create like any weird crashes or unexpected crashes or any unexpected panics in Rust, for example. And also because like another motivation was because Rust Bitcoin ecosystem basically already integrates fuzzing, either through direct fuzzing for the Rust Bitcoin crates or through Bitcoin Fuzz that does the differential fuzzing for the different crates and different implementations of the same projects. So, and BTK is one of the few missing with some other crates from Rust Bitcoin that doesn't have like a huge amount of fuzzing. But yeah, like the wake-up call was actually the Q4 of 2004 audit that was led by Antoine Poisson, the Rosier for the handle on the socials, and also funded by Sparrow, and the Wizard Sorting team did the audit for the BTK library prior to the 1.0 release. So that was one of the things that I wanted to have before doing the 1.0 release. And actually through the audit, like Antoine introduced two initial first targets, like just for the proof of concept, and also to help him to do the test for the audit, and instead of going through each test and doing all the tests manually. And it helped find some issues and some bugs, like crashes and panics due to unhandled like inputs for amounts and other persistence related issues. And those were already solved prior to the 1.0 release. So those were solved, the ones that he found on the first target that he wrote. And overall, like on the audit, like you can see on the Bitcoin dev kit blog post, there's a link there for the audit, and And he mentions that like the library already has good test coverage in general, but fuzzing is the missing spot and the missing thing or the missing piece for to have like be more comfortable with the APIs and how the library works. And even there's a phrase like BTK has no fuzz coverage and its modular architecture makes it adapted for fuzzing. This is probably the highest value thing that you can implement further to give the assurance of the quality of the code. And it's something that I started working on last year after all the releases and when I got some time to focus on this, and have been trying to work and became stale and I didn't have like a final target or a final fuzz target for it, but it was like a huge journey, and also discussed with Bruno and Eric. I'm not sure if Eric is here. Oh, yeah. I was the clone one. So they helped me like to learn a little bit more about fuzzing and how I could implement and how I could like improve the Antoine's fuzz targets. And I thought that it was easy, like fuzzing. You just need to plug the lib fuzzer or call cargo fuzz, and just runs and it finds bugs and it will help you with your library. But it's not an easy task. So it's more like I want to share all the problems that I faced and how you can prevent or know beforehand when you're trying to implement fuzzing on your application. So just adding like to the coverage and the tests argument that Antoine mentioned, like this is from his audit report. You can see that we still had like all the crates in the same workspace. We later moved on and moved the BTK wallet to another specific repository, but you can see that overall we have like pretty good function and line coverage and code coverage in general. Code coverage and test coverage is a weird thing to discuss. Like in my previous industry job, like we had like good coverage, but we usually said that doesn't like help much or doesn't say much, because if your test is not implementing what it should test, you just have like coverage and you're just covering what you did, but not really the problems that you can face and all the behaviors that you want to expect. And I just got from the current BTK wallet, we still have like pretty good coverage on some part of the code. There are some ones that are 0 or even low percentage, but those are not really testable, and there's some issues and false positives from the coverage tool that we use. Even Nimius was doing like an issue to change the tools and to improve like this, to be more accurate on how all those test coverages really show in the data that we want to know about it. And this one is for the BTK repo that has the workspace of the BTK chain, BTK Explorer, BTK Electron, and all the other crates. And also it has overall pretty good coverage. And these tests usually are focused on more specific part of the code and more specific files. So that's why we also have like small coverage percentage on other files. And even though like we have like a BTK test amp that helps you test and build all the scenarios and all that you need to do with the wallet, but overall you have like pretty good coverage, and fuzzing was the next step for adding better testing and better infrastructure for the BTK. So I don't know if there was any other like there was one from Eric in the morning, but and I'm not sure if there's any other talk that goes into fuzzing in depth. But I would like just to give an overview for anyone that doesn't know about it. So what's fuzzing? Basically, the concept is not new. It's like something 30 years old and was basically initially used to test the Unix CLI utilities. And then it's just a method for testing that you just generate random amount of data and random amount of bytes and inputs to try and pass to your application and your APIs to test the behaviors and what happens and the errors that can happen are handled properly. And there's like black box fuzzing. That's basically you just generate random data for your inputs. There's feedback guided fuzzing. That's the gray box fuzz, and also some useful terminology that I got from the AppSec guide is just the system under test. Is the code being tested, for example, BTK wallet. The harness is the function that wraps the system under test. and feeds the fuzzer generated random inputs to it in order to test, and also like mostly where you have your harness to write your fuzz targets that you want to run and test about it. The corpus is just the evolving set of test case. If you, for example, take Bitcoin Core, you can go to Bitcoin QA assets and see all the corpora or the assets that you can use to start fuzzing with an initial seed corpus, for example. You just compile all the test cases that the fuzzer generates and also can use as a seed corpus to provide for bootstrapping an initial set of inputs that are valid inputs and also helps the efficiency of the fuzzing. And those are basically the key terminologies. And how it works, basically. More like a mutation-based algorithm where it tries to generate inputs, test it, goes to checks if the code paths are being reached, and if it's not being reached, try to generate new inputs, and tries to drive the fuzzer forward, giving new inputs that covers more ground and more code. So through the coverage, like you can also use instrumentation with like devconf or any other tool that you want to check if your first target is actually reaching the paths of the code you want to reach, and it's not like stuck in a weird part of the code that's not testing any other, because the fuzzing can keep go running and you are not sure it's reaching all the code that you want. And basically it tries to generate any input that causes unexpected or unhandled errors. For example, panics in Rust, crashes, out-of-bound memory, out-of-bound indexes or out-of-bound memories. And here's like just like a snippet, an image to show like the further runtime. Just generate random bytes and a random byte stream, passes to the harness that has like the target implemented, and executes like the system that you want to test or the API or the functions. And the instrumentation also can check like for the conversion for all the other things that you can use. There's some other instrumentation, I think Eric can correct me if I'm wrong, but for example, you can use custom notators or even other approaches or other stuff that you can help with the instrumentation. And even the lib fuzzer one has like plenty of options for those that you can see in depth on the documentation. So what fuzzing can find? Basically, crashes or panics, as I mentioned, like any unwrap that we didn't handle properly and just like giving a shot. Like I'm not sure if you remember, because of the Cloudflare outage, was basically an unwrap that was being reached. So unwraps are pretty bad. We usually don't use unwraps in production code, but there are some panics or assertions that you can maybe forget in the code or didn't handle properly, or any other unwraps in downstream libraries that are not handled properly, or any other error variants that they're not handling as expected, or overflows or out-of-bound access. Those ones, overflows actually was one of the things that Antoine found on the audit, like because we wasn't using like all the APIs, the Rust Bitcoin amount that handles those. We were using like user32, i32, or any other integer that you want, and that could lead to some panics and issues that he found. It also can find some invariant violations. Basically, any business logic failures that are not handled properly due to like the state of the wallet or the state of your application not being reached in the way that you were expected. And this is where like mostly of the fuzzing that I'm trying to do in BTK lands on. Because you need to have like the state of the wallet or the idea of the scenario and the behavior that you want to do, and that's like the main thing that can find like invariant violations on that one. And like basically broken logic, like for the simplest case, like this serialize an input that doesn't works or have some weird problems for an unhandled type of input. Idempotency and also like differential fuzzing that you can use to cross-test different implementations. That's something that Bruno and Eric does on Bitcoin Fuzz. And like I think like Bruno mentions that a lot, like only an additional tool and not like a silver bullet as I expected. I thought that it was like just a silver bullet that I could use and see and check all the problems that we could found on the library. But it's not like a silver bullet. It's just an additional tool, and it's not that easy to do as well if you are doing like complicated or complex scenarios and testing like a complex application. So just like to also continue the quick overview on how you can fuzz around and find out on Rust at least, you can check the documentation for the fuzzers in other languages, mainly in C++ and C. But in Rust, you have like cargo fuzz, is the standard one that basically wraps the lead fuzzer. You have the honk fuzz, that's the one that was done by Google or Facebook, I don't remember, Google, yeah. And it's another fuzzer that you can use. The cargo fuzz that uses the lead fuzzer relies on nightly. The honk fuzz doesn't need that. And honk fuzz is one of the main ones that Rust Bitcoin uses. I know that Lightning Dev Kit or Rust Lightning uses the tree, like has a different harness and a different way to build it, and you can run on any one of those. And then there's also AFL, that's American Fuzz Law. So you can try those. AFL, you need to do some C linking stuff to run with Rust, if I'm not mistaken. But so far, I won't focus on only fuzzer and the cargo fuzz one. And the cargo fuzz, as I mentioned, like the standard one and the pretty straightforward to use. So just as a simple example, like again, like the harness, just take the fuzz generating input and execute an API or a function. Straightforward one would be like to call with raw bytes. Like you can, for example, you're just trying to deserialize some type from bytes. You can just pass the data, and the fuzzer will keep generating random data and random bytes to try it and check which inputs panics or fails or are not handled properly. And there's also structured our fuzzing that's like on cargo fuzz, at least is available with the arbitrary trait that you need to implement a trait. That's the arbitrary one that helps the fuzzer to generate like data that aligns with the struct or the enum that you are waiting, and it's better than trying to just parse all the raw bytes with the fuzzy data provider or anything like that to build the types that you want. So you can just explicitly call like the fuzz target with the my struct, for example, that implements the arbitrary trait that the fuzzer will be able to call anything from that struct. So just one thing that I was working like a 3 week ago or 4 weeks ago on office hours with Eric, it was trying to use structured or fuzzing in the BDK fuzz target that I was trying to work on. And because before I was just relying on the fuzzed data provider, that's another creating Rust, that's basically a re-implementation of the fuzz data provider from the fuzzer that also core does, has all the coding there. And it was quite hard because I had to parse all the bytes that I want. I had the input, the fuzzer to generate the input of the size of the bytes that I needed to generate and reach some part of the code. And it was really slow, like as I'm going to mention, the straightforward approach, like raw bytes, it's pretty slow and really consumes a bunch of cycles to reach the amount of size of the input that you need to reach the code path that you want. But this is like a simple example that I was trying to do with the arbitrary trait and the structured fuzzing. So instead of like receiving the raw bytes, I basically created like a fuzz input that has like the operations, the sequence of the operations that I want to apply in the wallet. For example, I have the wallet operation of apply update that tries to update the wallet with chain inputs from the blockchain sources that you can have. Create a transaction that has like the fuzzy TX builder, that's another implementation for the TX builder and for the sign options, and also persistent load that tries to persist on the SQLite in-memory database. That's another problem that I'll try to mention in depth in the next slides. But so with that, I just created like a wallet with the same descriptors always to make sure that I'm not testing that, because the descriptor parsing and all of that are being tested in Rust script and Bitcoin Fuzz. So we don't need to test that again. And for each operation that the fuzzer generated for the fuzz input, I can just do the operations that I need and call the codes that I need. And this was basically before I needed to parse the data, check like for, oh, the byte is 1, I do this operation. If the byte is 0, I do this operation. If the byte is 3 or any other, I do another variant of the operations. So this helps a lot on not having like all the utils functions that I needed to handle all the different types of bytes and the different types of things that I needed to create. So for example, I have the first text input. Instead of trying to generate the text ID, I just mention that I put the type that I needed here, and the arbitrary will tell, the fuzzer will try to create a valid type for that and not just random ones. I have the first text output, the transaction, the anchor that I need for the updates, and then for the chain information, and the checkpoints that I need to create for the local chain. That's basically our view of the chain. And with that, I can like create a fuzzed update. It's another implementation of the type of the arbitrary trait. And with that, I can build the transaction easily. Even like the transaction itself, it's one of the steps that I want to try in the future, is to use directly the transaction from Rust Bitcoin. If I'm not mistaken, it already implements the arbitrary one. You just need to pass it as a feature when you're using and calling the Rust Bitcoin crate. So it's something that I need to improve still. But this makes a bit easier using the arbitrary and the structured fuzzing makes it a bit easier to write the code. It can be a little bit more complex on some scenarios, but it's way easier than trying to use fuzz data provider and getting all the bytes that you need and try to do that. And even like we tried before to do a bunch of macros to panic while you was like consuming the byte stream, and only succeed once you have like a byte stream of the size that you need to create that type, and panic and exit while you didn't have that size. So the code just didn't fit on this one, so I just added the continuation. But with that, you can also like build the anchors, build the CNET for the unconfirmed transactions, and like from the data that the fuzzer generates, you can actually build a block hash from the byte array with the valid one, and doesn't need to keep the fuzzy iterating and wasting a bunch of cycles with that. And then you can build all the other. You can build all the other types that you need, like. So yeah, with that you can also like in the end build the TX data you need to actually apply to the wallet to do the operation that's the apply update that you want. And like there's a catch with the structural fuzzing, that because like you can reduce the amount of cycles that you want to create inputs that you want to pass to the wallet, but it can be like a problem if you want to build like a seed corpus or corpora from the start, because you don't know all the bytes or all the data that you need to pass for the fuzzer in the beginning to give a good strap, because it needs to parse the specific structure that like the fuzzy update, and not like for example PSBT, that's easier to just get all the PSBTs from the text vector for the bit and pass for the fuzzer as a bootstrap. You can't do that with the structural fuzzing, like at least not in an easy way. You would need to build like a parser to parse from the test vector, for example, or parse like transactions to build the structure that you need, and get the bytes to that and pass for the fuzzer. So that's like an issue with the structural fuzzing, and a challenge that I faced when trying to use it. And like just like an overview of some improvements that you could use, like seed corpus, to not like start the fuzzing from the ground up and just waste cycles with that. You can just like pass, as I mentioned, some data from the test vectors or some expected data that you know that's valid, and then we'll will catch some errors that are valid for the corpus, for the fuzzer that's working. Dictionaries, I did one. This one I didn't use, but I think like the other folks use this for improving and guiding the mutations for the fuzzer, and also the instrumentation one that's using for coverage to check your fuzzing in your fuzzer fuzz targets really reaching all the codes that code paths that you need. And also you can also try other tools that might work better in your platform or in your environment, for the home fuzz and AFL, for example. And also test like do like, for example, as Rust Bitcoin does, that has like the target implemented, and you can call the target with different fuzzers because it's all implemented. Do test macro that handles that for you. So yeah, like I'm not sure how with time, but now it's the biggest issues and the challenges and issues that I faced. Because as I mentioned, like I thought that it would be easy and I could do that like one sprint or a few weeks, and that would be done, and just let the fuzzer running for a while and see what I found. But yeah, like it's not really easy. A few challenges would be to actually like what we can fuzz about it, like what we want to fuzz and what we want to test. So not every function benefits. Like for example, BK, we don't have like a deserialization for PSBT. We use that from Rust Bitcoin, so we can't test that. We actually need to test and fuzz all the states for it. And also it's a slow feedback loop, like you implement your target and you let it run for a while, you check if it's like reaching the code path that you want, and it's helpful or not. And then you see that you had a problem in your target, and all the corpus and all the tests that you created, like basically waste, and then you need to do all it again and try to do and reiterate that. I'm not sure if anybody knows any better way to speed the feedback loop and also improve and help the cycle of the iterations and how you go back and forth from the target, so you can finally reach a good target. But please let me know if you know anything like that. Interpreting results, like when I first did the target, I found some crashes, but it were not valid crashes, because it's not like a real world problem that you would face. It's just because we had like a debug assert and assert like that panicked for a reason, and it's already fixed. We don't have that problem anymore, but it's something that wasn't like a real world scenario. It's something that you couldn't reach, or something that wasn't a real vulnerability, but something that I found on the target, and I needed to update that, and also the source code, and also the discussion and the challenges to choose if you want to do like raw bytes approach and just using the fuzzy data provider and parse all the data that you want to your type, or you just want to go ahead and try the structural fuzzing. In my opinion, like in my vision, the structural fuzzing was better to have a better code and not like a bunch of macros or something that's weird to comprehend, or any other person wouldn't be able to maintain that without like spending a bunch of time to understand it. So the structural one helps with that. So you can just have like the struct that you already have on your code, just to implement the arbitrary trait, and that's like the type that the fuzzer will generate. So everyone knows what that structure is about. Everyone's, for example, BDK knows what the structures for the wallet are, or the transactions that are actually done in the Rust Bitcoin one. So those are pretty easier to navigate and to understand the code and review the targets actually as well. So you don't need to have like a macro that try to parse U8, and there's not enough bytes, so you can't construct a specific type. So you get rid of that problem at least when we're reviewing and interacting with the code. But as I mentioned, like the thing that I had in mind was, oh, this is easy. There's a few low-hanging fruits that I can use, but not actually, because like all the public APIs are basically well typed that uses Rust Bitcoin, Rust script and types. So there's no like test that we want first to just check the serialization or deserialization. That's already coded for by the other downstream and upstream dependencies. So actually, like there's no real low-hanging fruits for the project. That's what I found, and we just can't like serialize or deserialize the input there. We don't need to test that because there's already covered by the other projects. And the thing that that I had in mind in the way that you can test for this application at least is that like, can I break BDK with valid, but like adversarial or different inputs and or any behavior or state that you are trying to apply to the wallet that are not expected or unknown. So that's the way that we want to test it and use fuzzing for BDK, and we don't really need like the serialization or deserialization logic. Those are the most brainy fruit ones that you just call the fuzzer to generate the byte stream and try to check if the serialization, deserialization are working properly, but that's not like the case for BDK. So stateful fuzzing is really hard and slow. That's what I found, like one of the problems, because you need to have like all the state of the wallet, and the fuzzing needs to keep generating inputs to reach a side of the input that's valid and can reach the states and the code path that you need. And it's basically like for BDK and for the first target that I had, you basically need to create the wallet and also persist it if you're using like the persistence. As I mentioned in the past, like persistence is another problem because I know that in core they mock the database to do like the persistence when you need to do the fuzzing, because that's pretty slow. Like any database call can really slow down the fuzzing and all the iterations that you're doing. And like BDK, you do the creation, the persistence. If the wallet has the persistence feature enabled, you need to create all the chain data that you need, like all the checkpoints for the local chain, all the transactions that are trying to apply to the wallet, all the blocks that transactions have as anchors, or it doesn't have anchors. It only has like the timestamps for the observed in mempool or observed in block. So you can call all the other methods that rely on the text graph that needs those updates. You need to apply the update on the wallet, check like the updates like valid or not, and also you need to test the building and signing transaction with all the updates that you apply to the wallet with all the balances that you have. So this is the whole state that the first target needs to test, and that's why like it's really hard and slow, because you need to really pass for the target, the behavior that you want the wallet to achieve, and all the operations that the fuzz need to generate the types and the data that it has to achieve those. And with that, you arrive like in complex targets, even if you're using raw bytes or structural fuzzing, the targets will be huge and really complex and not just calling like serializations. So it makes it really hard to write, and it's slower to run, like slow executions per second, and slow in reaching the type of inputs that you need to reach the code paths that you want. I have some images that I will show with how slow that is, and also like requires like this bigger like fuzz input into space, so it really takes a while to go on. So just an example, this one is using the raw bytes approach that I had, like an node commit. Actually this one is using the structured or approach one. You can see like the executions per second is like 26. That's pretty slow and will take a while for having like to really reach an input that's valid and will give problems for the wallet, and can generate like malformed but valid input that will reach an inconsistent state for the wallet. And this one was for the raw bytes one. I still need to debug why the structure is lower than the raw bytes one. Maybe the logic that I did is not really sound on the new target. But this one was a little bit faster, at least for some iterations. When I was using like raw bytes, I think that was able to reach more paths and more executions in a better way. And I found at first the problem that I mentioned only with the raw bytes approach. So far, I didn't find anything new with the structural one. And actually, it's a problem because I'm not sure if I'm not really reaching any problem, or the first target's wrong, so that's why I need to keep iterating and trying to see the coverage is reaching what I want to do. So just as a compilation, like a compilation of the few lessons and challenges that I wanted to mention. The initial target helped a lot from Front One and from the audit, but it's like not a simple job as I thought to just replicate that and make it maintainable and reuse it. in the code, and also something that we can really push for the master branch and for the upstream repository, and also making it well documented and well supported in CI and all of that anyone can run on your server or in your CI. That's also like really hard. And also someone that Blue Matt mentioned, something that Blue Matt mentioned in the PR is having like the harness support for running multiple fuzzers, and that one also can be really hard to have like all the support, for example, that Rust Bitcoin has, to be able to have a fuzz target that runs on any other fuzzer implementation. And using the structural fuzzing makes it harder because the arbitrary, I'm not sure if that's supporting AFL and Home Fuzz. I think Home Fuzz and Liquid Fuzzer is. I'm only sure for Liquid Fuzzer. And you can, but I would say like you should start small. I tried just to do the whole wallet thing at first, and that really was a problem to try to implement a target that did everything at first. And it was like, we took a step back and tried to implement, I just need to create the transaction. This is the fuzz data provided by the structural fuzzing that I need to do that, and then iterate for the next action that the wallet needs to do, and compose the fuzz target with that at first, and repeat the iteration of that. It's easier to know that the fuzzer is reaching where you want to do. At least in my opinion, and for now, like on the way that's maintainable and well documented, the structural fuzzing is the key, or the way that we should go from now on, and because it makes it easier for other people to review and also to port that code to other places. And besides that, like currently it's lower than using the raw bytes, but it's way less FMS than having like a bunch of macros calling fuzz data target, fuzz data provider, and handling and parsing all of them. So yeah, I'm not sure if I went pretty fast, but thank you very much. Thank you. So we got some time for two to three questions if you want to discuss anything. Yes?
You mentioned a few slides ago that you recommended doing some sort of using multiple engines like Bitfuzzer and Fuzz and things like this. Yeah, that you said that user tools. Did you make it in the beginning?
No, I didn't implement like to try to use other ones. I tried to locally to use Home Fuzz, but as I mentioned, like in the lessons, to start small and to do one thing first and then move to the other ones. I just want to first get the targets right in one of the fuzzers, like the Fuzz, for example, and then add support for other harnesses and all other like fuzzers.
When using random bytes, are you just like doing exhaustive search where you go through like generate some random bytes, check if it was like the test set, it's repeats?
Yeah, what the fuzzer does,
like
the fuzzer like just generate random bytes, and it's your part of the job, like in the target, to parse the bytes to get like the amount of bytes that you want to create a type.
The feedback load does it apply what was event whenever you do the test, or just like try one thing one time and try another until succeed. Like that's some search algorithm implemented, or just
You don't need to implement that yourself, like that's part of the fuzzer. I'm not like sure if I will explain that in a good way, but yeah, the fuzzer has like the mutation evolutionary algorithm, and that checks the coverage and the path that it reaches, and that you can think of a search algorithm for the best inputs for that. I'm not sure if search is the best name or not.
So you mentioned the arbitrary and the problem with the bootstrapping order. Like the series I understand correctly is because when you change the structure of the data structure, it's going to change exactly about how it's going to consume all the raw bytes from whatever is being feeded from the fuzz, right? And then that invalidates the root world.
Yeah, that's the issue of changing like how your fuzz target is written. So the steps that it takes or how it parses the raw bytes. The problem with the structural fuzzing is that, for example, using raw bytes, you can just copy the PSBT, for example, testing like the serializing PSBTs.
My question is more related to using arbitrary.
Yes.
When you like have this structure and then you need to change it, and then it's going to all validate the entire report, right?
Yeah, but that's the same for raw bytes and arbitrary.
Yeah.
If you have like an API breaking chain in BTK and you need to change the struct that you're using, like that will invalidate the corpora.
Yeah.
But the issue that I mentioned, like of not being easy to create like a seed corpus or to bootstrap applications that, for example, using raw bytes, if you're testing like serialization, deserialization of PSBTs, you can just get the bytes of the test vectors of PSBTs that are valid or broken ones that you can put in the corpora to bootstrap it, because it's just bytes of the PSBT, and that's what the serialization function expected, the fuzzer expects. But if you're using like arbitrary and it expects like a TX update struct for BTK, it's really hard to build that by hand in bytes, and not only that, all the input that the fuzzer needs to have put it on the corpora.
So like this was like what I needed to actually make the real question, which is like, is there like a way for you to have like a arbitrary like to the opposite word, like you passing the structure like the updated like let's say you made a change, breaking change, and now you want to give him like give the arbitrary break a good looking struct, so that it gives you back the bytes so you can like bootstrap this.
Yeah, I'm not sure if there's some many tools that, but it would be pretty hard and not a cool job to do. But that's an issue. Like if you have that tool, you could like refactor the corpora that you had to the new API, but I'm not sure there's any.
Yeah, because then you could have like a Rust code to be like the bootstrapper.
Okay.
Right.
Yeah, but I'm not sure if there's any.
How it was for you and your team to introduce the fuzzing there? How it was for you to review, understand what fuzzing is, to review your PRs? Because when I introduced bootstrapping with you, mostly I relied on Eric's review.
Yeah, the same.
And then with time, then the people there start reviewing it. How it was the process for you?
Yeah, basically it was Eric and Bruno that helped me. I think like only now we have another contributor that's interested in it, like SDMG15, that's like a Bitrust Builders one. Coding Free also showed interested in helping with the fuzzing. It's another contributor of BTK, but so far it's only us three, and for the last year was only me, Eric, and Bruno in my office hours or theirs discussing that. Because they are the fuzz masters, as we call it. That's pretty hard topic to know who to ask about. So we should be happy that we have like Bruno and Eric to ask about. Yeah.
Last one?
Last one? Okay.
So, related with the first question, do you think that it would be like a big difference between outputs from using one diffuser or another, or diffuser or confuser?
I'm not sure. I'm not sure if Eric knows about like, is there any difference, huge difference of doing like using EFL and home fuzz, for example? That one I didn't reach that step yet, so I don't know about it.
Yeah, I think they get like different feedback, and they can interpret different when you run with the fuzzer. So you might get like different in corpus running different fuzzers. So it's like the idea is run of them, but running with one at least is already pretty good.
Thank you.
Thank you. So yeah.